So in this case, again, we are going to consider the continuation from the previous exercise, actually same exercise, but another continuation from question number 6, which are now a little bit complicated questions that we are now having. So let's check how are we supposed to attempt these typical questions. Number 6, you are given BCD is a straight line segment. This is a straight line. That is what you're told. And what is it that you understand? Angles on a straight line add up to 180 degrees. All right, which is fine. Calculate the size of x, which is this x that we are seeing here. Okay? There were so many ways that we can use to calculate this angle x. Okay? One, we can consider that this is a straight line, and definitely we can obtain angle C, this other angle C here, from 180 degrees. Angles on a straight line, they add up to 180 degrees. So we're simply going to subtract 68 degrees from 180 degrees, which is the concept of what? The angles that are on a straight line. And you are going to obtain 112 degrees. Meaning to say this other angle at C is 112 degrees. Remember, there is the C, which is the external, which is the exterior angle, and this C, which is the internal, which is the interior angle. There are two angles there, but they form a straight line. Remember the adjacent concept of angles on a straight line. They must give us 180, so we're simply going to subtract that. But is it x? No, that is not x. Let's consider about x. ABC is a triangle where AC is equal to BC. So that's an isosceles triangle where I said the angles opposite to these sides must be equal. This side is opposite to x. So this angle at x must be equal to this angle that is at B. So if there is x here, we must also have x here at B. These two angles, they are equal. So by knowing this, how is it going to help us now to calculate x? Angles in a triangle add up to 180 degrees. So this x at A plus the x that we are seeing at B plus the 112 degrees is supposed to give us 180 degrees angles in a triangle. All right, so there we have got angles in a triangle. We have formed an equation that we must solve for x. We are back to our equations. So remember, x simply means this is 1x and this is also 1x. So we can add 1 plus 1, which is 2x. Okay, plus 112 degrees is equal to 180 degrees. So let's solve for x. 2x is going to be equal to what? We need to remove this, the 112 degrees that we are seeing here. We need to remove that, this one. So remember from our equations, I said you are going to take it to the other side of the equation. The moment that it crosses the equal sign, it is going to change its sign. It was a plus, it jumps the equal sign, it becomes a minus. So that's minus 112 degrees. So that means 2x is equal to, we can subtract that from 180, that was going to give us 68 degrees. Then we can divide by 2. Remember, a product, divide to remove the number that is multiplying. So therefore, our x was going to be equal to what? You divide this by 2, you are going to obtain 34 degrees, just like that. So meaning to say this is 34, this is also 34 degrees. Okay, was this the only way of answering this question? No, we could have answered this question this way by understanding that these two lines are equal. That's another way that we could have used. We understand this is X and this is going to be X also at B. This concept was not going to change because that's an isosceles triangle. But remember what I said before about this angle, which is outside of the triangle, which is referred to as the exterior angle, the one outside of the triangle. It is equal to the sum of the opposite interior. This is the interior, but the opposite interior, which is this X, and also this X. We are supposed to get 68 degrees. The exterior. So if we add these two, the X and the X, we are supposed to get 68 degrees direct. This exterior angle is equal to the sum of the opposite interior. It's a property that you need to understand also on your triangles. So thus we can solve for X. 1X and 1X, that's going to be 2X is equal to 68 degrees. So simply divide by 2 by 2. That's an equation. We are now solving for X. So that was going to be 34 degrees. So still, you are going to obtain the same value of X that we calculated before, which is 34 degrees. So many ways. All right, number 7, you are given, find the size of X, then the size of H. So let's start by X first, the size of X. So there we just need angles in a triangle. There's direct angles in a triangle that up to 180 degrees. So if we take this X, we add it to this one, which is X plus 20 degrees. We add it to this one, which is 2X plus 40 degrees. We are supposed to obtain 180 degrees. That is angles in a triangle. We talked about this. Angles in a triangle. They add up to 180 degrees. So we added all the angles in terms of X. What have we formed? An equation that we are supposed to solve. Just like previously, this is 1X, this is also 1X, this is 2X. So we can consider the like terms, that is the terms of X. There is X here, there is also X here, there is also X on this part. So we're going to add all that part where X is 1 plus 1, which is 2, plus 2, which is 4. So that's 4X. Then the angles, we add them, 20 plus this 40. 20 plus 40, that is 60 degrees. And this is equal to 180 degrees. So we've added this. Then just like a normal equation, take this the 60 to the other side, it becomes a minus. So 4X was going to be equal to 180 degrees minus, it was a plus. So there, it will be a minus on the other side of the equation. So that's 4X is equal to the difference that we are going to obtain, which is of 120 degrees. So just divide by 4, that's a product. So divide by 4 both sides, you are obtaining exactly the value of X. And that was going to be 30 degrees. So that is the value of X. So therefore, we have got our X in that case. By simply solving an equation, angles in a triangle, they add up to 180 degrees. All right, there's another question that we left here. And the size of H, the size of angle H. Meaning to say, we need this H. According to the illustration that we are given on our triangle, H is given as 2X plus 4. All right, so just going to call this A. This is going to be B. All right, so angle H, according to the illustration here, is given in terms of X, which is 2X plus 40 degrees. 2X plus 40, 2X plus 40. All right, so you simply have to substitute because we need a numerical value, not an expression. So you must substitute the value of X that you calculated here in place of X. So 2X means what? 2 times X. Remember from our algebra. So it's 2 times X, which is 30 degrees. So that's 2 times what? 30 degrees. And whatever that you're going to get, you must add the 40 degrees that you are having there. So that is what you are going to have. So let us multiply and add this, or you can just use your calculator. 2 times 30 is going to be 60. Then we add the 40 degrees. So 60 plus 40, that was going to be 100 degrees. So our angle H at the end was going to be 100 degrees. Or you can just use your calculator. All right, so that was it. Let's see another question, which is question 8. Calculate the size of n. So n is this angle that we are given here, which is given as 2x minus 30. But as you can see, this is in terms of x. So again, the first thing is to solve for x. You must find x first. So to find x, we are going to form an equation. And this equation is supposed to be true. And how is it going to be true? Angles in a triangle, they add up to 180 degrees. That is true. From the statement which is true, you can form an equation. So this means the 2x minus 50 degrees added to the x plus 10 degrees added also to this 2x minus 30 degrees, we are supposed to obtain the sum of 180 degrees, which is angles in a triangle. So we have to find x first. Before we talk of the angle n, let's find x first. You are not given that, but you're supposed to know it. All right, so there's x, which is same as 1x. So let's go back to our algebra, algebraic equations. We're going to collect the like terms where there is x, 2x there. There we have got 1x, and there we have got 2x again. Then in terms of the numbers, the angles, we're going to work with the minus 50 degrees, the 10 degrees, and the minus 30 degrees. You combine those angles together. All right, so let's start with the numbers. I mean, the algebraic terms, 2x plus 1x. So 2 plus 1, which is 3. 3 plus 2, which is 5. So that was going to give you 5. Or just add on your calculator 2 plus 1 plus 2, just like that. Okay, then we move on to the angles. There we have got a minus 50, a plus 10, and a minus 30. So just simplify, direct on your calculator, minus 50. You add a 10 plus a 10, then you subtract 30 degrees. That is the concept. So you're going to obtain a minus 70 there. So this was going to give us minus 70 degrees. Like I said, it's minus 50 plus the 10 minus 30 like this. So it was going to give us minus 70. Okay, so that is the concept, which is equal to 180 degrees. We can solve for x. This time there is a minus, be careful. So the moment you take it to the other side of the equation, the moment it jumps the equal sign, it changes there. So this means we are going to have it on the other side as a plus. 180 plus a 70 plus. It was a minus, changes to a plus. Okay, so that's it. So 5x is equal to the sum of these two. We have to add these two, which is 250 degrees. So that was gonna be, sorry for that, 250 degrees like this. Okay, then we're simply gonna divide by 5. That's a product, so divide by 5 both sides. We obtain the value of x, which is 50. That was gonna be 50 degrees. So that's the value of x. Okay, so if this x is 50 degrees, what about the angle n that we are given? You see, it was not part of our question, but we had to calculate this x using the angles in a triangle. So for that x, then after that, therefore, our angle n is going to be, as you can see, there is 2x minus 30, 2x minus, remember 2x 2 times. So it's 2 times the value of x that you calculated, which is 50 degrees. Whatever that you get there, you must subtract 30 degrees, just like that. So you can use your calculator, or you can multiply 2 times 50, which is 100 degrees. Then you subtract 30 degrees, 100 minus 30, which is 70 degrees. So therefore, our angle n was going to be 70 degrees. Just like that. All right. So you can calculate whatever angle that you're given there. By substituting the value of x, you can calculate angle P, you can calculate angle M. So I want you to calculate those angles, substitute, then let me know on the comment section the answers that you're getting for the remaining angles. Just test yourself as well. Number 9, DNP is a straight line. All right, there we've got a straight line. Calculate the size of x and y. Okay, let's see what we've got here. There is a straight line, okay, which is fine. Then also we are given this indication, these two lines here, these two lines here also. So it means these sides are all equal. This side is equal to this side. This side here is also equal to this side. So in actual sense, MNP, this triangle is an isosceles triangle. Also, MND, this one is also an isosceles triangle. So be careful. Be very, very careful. So if this is an isosceles triangle, remember our concept, the angles opposite to the equal sides must be equal. So if this is 50 degrees at P, therefore at M it's going to be 50 degrees also. So thus we can calculate angle X. How? X plus the 56 degrees plus the 56 degrees that we are given here is supposed to give us 180 degrees. So thus we have formed an equation which we can simply solve for X. So that will be X plus, if you add these two, you are going to obtain 112 degrees, which is equal to 180 degrees. So let's solve for X. Simply take the 112 to the other side. The moment it jumps the equal sign, it changes its sign. So that will be 180 minus 112. So thus obtaining the value of X from what we are given. And this was going to give us 68 degrees. So this simply means that we have got 68 degrees here, just like that. And this other angle on a straight line, because you're given that DNP is a straight line. What is it that you understand about angles on a straight line? These two angles are supposed to add up to 180. So we have one of these angles. So we can simply subtract to calculate this remaining n. There are two angles, this n and this other n. So you can just call n1, n2. So the n2 is simply going to be the difference, 180 degrees minus 68 degrees. The difference is this other n that we are seeing on this other side. That's the difference from 180 degrees, which was simply going to be 112 degrees. All right. So what is it about this 112 degrees? How is it going to help us to calculate the value of y? Okay, we are back to that concept here. Remember here when you calculated x on this question here, when you said this is x, so this is also x because of the sides, then you form an equation. It is the same thing that is happening here. If this is angle y here, because of the isosceles triangle concept, this side opposite to D, this side opposite to y. So it means the angle at y here and this angle at D must be equal. So if the angle at M is y here, the angle at D is supposed to be also y. Just like what we saw here, this angle opposite to the equal sides. So thus in this triangle, in triangle MND, we are going to form an equation. Just like here, we are going to form an equation. There we have got y degrees plus at D, which is y degrees plus the 112. All this is supposed to give us 180 degrees. Angles inside of a triangle. That's an equation which you can use to solve for y. Remember, this is 1, this is 1. So let's add 1 plus 1. That is 2y plus 112 degrees is equal to 180 degrees. So we can solve for the value of y by first taking the 112 to the other side. It was a positive, so it's going to be a negative on the other side. We have to subtract that. So that means 2y is equal to 180 minus 112 degrees, which is going to give us 68 degrees. So 2y is equal to 68 degrees. Simply divide by 2 to find the value of y, and that was going to be 34 degrees. So meaning to say y there is 34, and that other y there is 34. They're the same. They're just one and the same thing. So thus, we can calculate whatever part, guys. Geometry is not limited. As you are working with the geometry, open your mind to anything that has to do with a geometrical, as long as it's a geometrical concept that you are applying there. And you must be able to give a reason to that geometrical concept that you are using to answer your question. So do revise as many questions as you can so that you prepare yourselves for the exams that are ahead of time.